Okay, you get credited for your team. Okay, now usually one person might carry the weight of the whole team, but that's your problem. That's your dynamics. You might as well face it. I like to bring in really sometimes the dark side of engineering. I really like to prepare them. Okay, because up to the point that they take my class, okay, they have this incredible notion that engineering runs the world. And I break and I shatter that belief. Okay? I sit there, that's not the case. Right? And then I cite examples. I'll sit there and I go, look at the iPod. As an exercise, I tell them, tell me exactly why is it that the iPod is successful? It is not the first MP3 player that's in the market, but why is the iPod? Because if it's technology alone, the first one that made the MP3 player will be successful. But why was the iPod successful? Why was it not the MP3? The other aspect is Windows. Okay? Take a look at Windows. You sit there, anybody that has problems with Windows, okay, will come back and go, oh, okay, you should do Linux. Okay, those that are Linux fans will sit there and do Linux. And you know that. Even Google. Okay, I am sure, even back in the basement, I am sure, Microsoft themselves have Linux servers that are acting as servers. Because they know Linux is much more stable. But then I tell them, I go, look at that, okay? There is something that everybody knows is technically more sound, which is Linux, okay? You can argue if Linux is more expensive than Windows, yeah, okay, that's why Windows is successful, but it's not. Linux is free. It is a free operating system. It is better, but yet, why is it that Windows is successful? This is where, if you guys think that technology is the key, shatter it. And those are the statements that I can actually get in trouble from the department. But these guys are seniors, they're not kids anymore. Oh. I can't say that as a freshman class, right? But a senior class, they might as well know. So there are other aspects, okay? The other thing that I tell them, okay, you guys been looking at the books, okay? You come up with a design, okay? Where do you think really the specifications comes from? Does the specifications come from an engineer? No. The specification comes from marketing. Yeah. So you need to know how to design to that specification. No matter what you think of it is, okay? Right. You can, and you may, some of you are fortunate enough that you will govern that, but most of you will not. It will come from marketing. It will come from something else. So what you need to change the perspective of, rather than you are governing it, your job is to be and is to make that judgment call. Because there's always going to be trade-offs in engineering. That is what engineering is about. In physics, there is no trade-off. Physics is absolute. You are here because you want to make a judgment call. You need to know what is good enough. What is good enough, not just from what the textbook tells you, is what you need to apply tells you. Okay? Because like Windows, obviously, Windows crashing. You look at any book, you look at any computer science, you go to any computer discipline, they'll teach you that is not acceptable. The problem with engineering is that if you do that, right, I would say almost 90% of the product out there will never get to market. Because nothing is ever perfect. Although the textbooks teach you to be perfect. So those are the dilemmas that students actually get to when they get into the workplace. They also have that problem.
Oh, so I can say, so you teach your students about the process of thought for the first 21st century in engineering department.
I don't know about that.
It's entirely different than the old school of
well, that's because they've had enough of that. I mean, it's not that. I mean, believe me, the entire curriculum can't be taught in this style. That does not work. The reason that I can do it, the reason that I can do it is because I know these students have a solid foundation that comes in. So to me, my philosophy is, look, you guys have gotten enough theory already outside of my class. You're not going to get any theory from this. You have to bring the theory in. What you do in my class is to apply it.
Yeah, because the 21st century, the one who would succeed is if they understand your teaching the process of thought for the first 21st century. At least
a little bit of it, a combination of it, in the engineering part of it. I mean, a little bit. In applied engineering, yeah. A little bit.
In the engineering department, yes. Not everything, of course, yeah.
You know, but there's also a side of theoretical engineering that doesn't necessarily. But for the practical side, you want to have a combination of the thing. You don't want to be extreme on either end, on either side, because you can be extremely practical. But the problem is the future will never come. Okay? Because if you don't understand, if you cannot create the theory, I mean, the key is creation. Okay? You can sit here and learn. You can go to class, you can get all the A's and so forth. But if that spark of creativity, okay, if that spark of creativity is not in you, okay, the future is dead.
That's right.
Right?
So if
In either end. So I've seen students that are brilliant from a practical standpoint, but then when they come into a problem that is actually a physical or theoretical foundation problem, right? Then they're going to hit a wall, and then they can't solve it. So the interesting thing is, I teach both here and state. In state, I see the other extreme. Okay? So here, most of them are very theoretically heavy, and I need to sort of bring them down a little bit to be a little bit practical so they're better rounded. In state is the other way. A lot of the ones are actually very, very practical, but the problem is they hit a brick wall very quick because they do not have the mathematical and the theory background to really understand what's going on. So they are building stuff, and they build incredible stuff, but engineering-wise, it's wrong. It's like, what are you doing? Yeah, and they'll argue with you. I mean, literally. This Friday, they just had a showcase, and I love to go to the showcase because I'll press them. I'll argue with them. And they'll actually argue. I'm like, you've got to be kidding. Not that I am sitting there trying to brag that I'm more theoretical sound or what have you, but it's like, fundamentally, they are like way off. They're actually way off, and it's like, oh my God. And then at some point you just give up, because it's like, okay, you have your belief, and you're going to realize this is not going to work.
Okay, so this is very useful for the viewers of Kabari News, especially young person who are going to study UC Berkeley or anywhere. What is the challenge and the differences between your undergraduate students and your graduate students?
Okay. That's a good question. The interesting thing is, believe it or not, okay, and this is something, it's sort of hard, and sometimes it's sort of sad, you see, but, and this is why you'll see that a lot of really brilliant creativity, okay, a lot of them, really are sparked by the youth. Okay? And then it depends on the caliber of the students that you have. The undergraduate projects, believe it or not, are actually way more creative than the graduate projects.
Really?
Yeah.
Why is that so?
Why? Why? Because they are willing to take more risk because they don't know what they don't know. They have more of it. So they actually take more risk. That's why you see, now I sort of understand when people say that the bright idea, the youth is the future. And it is. The youth is the future. Because as they're coming up, they are willing to take a risk. Okay? If you don't teach a small child is much more willing to jump off a bridge than you are. Because you know you can get hurt. A child may not. Right? A young child is going through, they'll sit there and they'll jump. They'll go until they get hurt. Then they'll stop. So on the 5th stair that they jump off, now my knee hurts a little bit. They might not go to the 6th or the 7th. Okay? And it's the same thing with you. You may even not start out. Now you're not even go on the 5th stair.
Right.
It is the same thing in the creativity of their projects. And the interesting thing is not only that, it's not just time and experience and learning. Because I teach the course, okay, in the spring, which is their senior year. Most of them are seniors. Then the next one is the fall. I get incoming graduate students, and I teach them as graduate students. And the course basically is the same. Structurally, it's the same. Okay.